Hello students, today's lecture is on the problem set for the motion of the center of mass. In last problem set I discussed with you how to locate the center of mass. Now today's problem set is on the motion of the center of mass. How the center of mass moves. When the velocity of center of mass remains constant. When the center of mass of the system of objects, system of bodies gets accelerated. We have to understand the basic rules for that. First of all, number one, suppose there are so many particles, 4, 5, 6, whatever may be their number. I want to find the velocity of center of mass of the system of particles. The rule is like this, that I have already told you, and I have already delivered a lecture on that. So that is VCM, velocity of center of mass, is equal to m1 v1 plus m2 v2 plus m3 v3 divided by total mass m1 plus m2 plus m3, that's total m. This is the velocity of the center of mass of the system of bodies, right? Okay. So if there is no external force on the system of these bodies may be interacting with each other. ये एक दूसरे पर फोर्स एक्सर्ट करते होंगे, लेकिन कोई एक्सटर्नल फोर्स नहीं है. If there is no external force on the system of these bodies, then we say this center of mass of the system of bodies, the velocity of the center of mass of the system of bodies, either it will be at rest or it will move with constant velocity, right? So I will write it down so that you understand that is either 0 or constant if external force on the system is 0, right? So when will the center of mass, when will the center of mass of the system of bodies will accelerate? The center of mass of the system of bodies will accelerate only if there is external force. The system of the center of mass of the system, the center of mass of the system, center of mass of the system will accelerate only if there is external force. So center of mass जो है, velocity of the center of mass, that will change only if there is external force. Internal forces of all these bodies together, they cannot change the velocity of the center of mass of that system. That's all. This is the basic rule, right? Number one. Number second, let me design a problem. Let me design a problem. An object is launched in a gravitation. It's a projectile motion, and this body goes along in a projectile motion way, and we know that it follows the parabolic path. When an object is thrown into the space, where under gravitation, it follows the parabolic path. If the object does not go quite high, while we take this acceleration due to gravity to be constant, both in magnitude and direction, in that region of space where we suppose acceleration due to gravity to be constant over a little distance, the projectile will move in a parabolic path, right? So under the gravitational force, the center of mass of this object goes in a parabolic path. But what happens? The object goes and it explodes into pieces. When it explodes into pieces, different fragments go in different directions. My question is, what is the path of the center of mass of those fragments? The path followed by the center of mass of the fragments fragments. ये जो ऑब्जेक्ट एक्सप्लोड हो जाता है, अंदर से फट जाता है, इट बिकम्स फ्रैगमेंट्स, एंड वी हैव टू सी उन फ्रैगमेंट्स का जो सेंटर ऑफ मास उसका पाथ क्या है. दैट्स आवर क्वेश्चन. द आंसर इज द सेम एज same parabolic path. Why? Because the center of mass of the object was following the parabolic path. Now the fragments, their center of mass will also follow the parabolic path. Why? Because there is no any additional force. It was following a parabolic path under gravity, and there's no any additional force to change the parabolic path, because the forces were internal. The explosion, or when it was split into fragments, the force was not external, it was internal. So internal force will not change the path. The path is already parabolic under gravity. So the answer is the path followed by the center of mass of the fragments is again parabolic, because there is no additional force. The force is only gravity, and under gravity it was already following the parabolic path. And in the new scenario, when it becomes fragments, the force again the same gravitation. Therefore, there is no additional force. So it was already moving in a parabolic path. Now also, the center of mass of the fragments will also follow the same path as parabola. And that was the question. An object launched follows a parabolic path. There is an explosion inside the object. It becomes fragments. The center of mass of the fragments also follows the parabolic path, because there is no any additional force. The only force acting on the fragments is gravitation, and it was already following the path of parabola, and now also it will follow the same path as parabola. Third question. Okay, this is one more problem. There are two two bodies having mass of 200 grams, and second mass has 500 grams. First particle has the velocity of 10 in the I direction, and second particle is moving in a plane of xy having velocity 3i plus 5j. Means it is x component has the velocity, x component is 3 and y component is 5. And we have to find the velocity of the center of mass of this system of these two bodies. So which formula I'm going to use? Which formula? That is m1 v1 plus m2 v2 divided by m1 plus m2. This is the base formula to find the center of mass of the system of bodies. Here we have only two bodies, therefore only two bodies here, right? So velocity of center of mass is equal to, क्या लिखूंगा, m1 का क्या लिखूं, 200 grams, so that is 200 into 10 raised to power minus 3 kg into what is velocity, that is 10i with direction I, plus what is m2, that is 500 into 10 raised to power minus 3 to make it kg, and what's v2, that is 3i plus 5j whole divided by, that is sum of the masses, that is 500 plus 200, that is 700 into 10 raised to power minus 3, right? So it is VCM is equal to 3 zeros finish, it is 2i plus 15 into 10 raised to power minus 1 multiplied with these two zeros, I plus, that is 525 into 10 raised to power minus 1, because 10 to the power minus 3, 2 zeros, 10 to the power minus 1, j divided by 7 into 10 raised to power minus 1. Okay, now it is VCM equal to 2i, it is 2i plus 1.5i plus 2.5j divided by 0.7 here. this one. VCM equal to 2i plus 1.5i, that is 3.5i plus 2.5j divided by 0.7. Now it is divide 0.7 to 3.5 and 0.7 to 2.5. So it will become VCM equal to, when I divide 3.5 to 0.7, it will become 5i plus, if I divide 2.5 to 0.7, it will become 25 by 7j. That is the answer. This is the velocity of the center of mass. Of course, we can find its magnitude. That is root of 5 square plus 25 by 7 square. And you can find the direction, theta, that is the tan inverse 25 by 7 divided by 5. So once you have a vector, in terms of components, you can immediately find its magnitude, you can immediately find its direction. Right? Now, this was third. Let me go to the fourth problem. This is a plank of length L and mass M, capital M. And a person is there at one end of the plank. ये जो person है, ये plank के एक end पर है, और everything is at rest. Total system is at rest. The man is at rest, the plank is also at rest, but the plank is on the frictionless surface. There is no friction between the plank and the surface. So this man and this plank must have some center of mass somewhere. There must be a center of mass of the system of man and this plank. कहीं पर होना चाहिए center of mass. Wherever there is, that is, let it be somewhere. But now the man starts running on the plank. When man starts running on the plank will move in the opposite direction. Why? Because there is no external force. When there is no external force, the forces are internal between the man and the plank. The total center of mass of the system of man and the plank should remain where it is. So the man takes the center of mass of the system in the forward direction when he moves forward. Therefore, the remaining part of the system, I mean the plank, should take the center of mass in the backward direction, so that the net effect on the center of mass should be zero, so that the center of mass remains at rest. What we have to do? What the distance the man moves related to the ground? ये जो plank है, ये कितना पीछे जाएगा? No. ये जो man है आगे गया L, यहाँ तक गया L गया, but on the plank पर ये L गया, पूरा plank का length से cover किया on the plank. But we have to see how much distance it covers with respect to ground. अगर ground पर कोई observer है, उसके लिए इसने कितना distance cover किया? इसके लिए इसने ये L cover नहीं किया, इसके लिए इसने सिर्फ L minus x का distance cover किया, क्योंकि ये जो plank है पीछे x चला जाता है, और ये net distance, ये man जो है net distance से L minus x ही जाता है for a person at rest. Ground के लिए. For ground observer, he moves only L minus x distance. For the plank, as an observer, for the plank, with respect to plank, he moves the full distance L, because he goes from one end to another end. तो हमें देखना है कि L minus x का distance हमें निकालना है. So, what is the concept? The concept is the center of mass of the whole system remains where it is. There is no change in the center of mass of man, no. Of this L, no. The center of mass of the whole system remains at rest, where it is. So, the center of mass taken by the man, the center of mass of the system taken by the man in the forward direction. What is that? M by 3 into L minus x. This is the center of mass of the system taken by the man in the forward direction. Center of mass taken by the plank in the backward direction should be equal, because the center of mass has to remain at rest. जितना man ने center of mass system का आगे लिया, उतना ही जो plank है center of mass of the system पीछे ले जाना चाहिए. So is equal to m into this x, because the plank goes back in the x direction. Okay, so m gets cancelled. L minus x is equal to 3x. 4x is equal to L. X is equal to L by 4. But what is the distance it covers with respect to person on the ground? That is L minus x. That is the displacement distance. That is L minus x is L by 4. That is 3L by 4. Answer. Let me go to the fifth question. Okay, this is the fifth question. What is fifth question all about? These are two masses, m1 and m2, on the x-axis, right? And they must have some center of mass somewhere. Okay? Mass m1 moves to the right. ये जो mass m1 है, it moves to the right side in the positive x direction by d, small d. What is the displacement of mass m2? ये m2 का displacement कितना होना चाहिए? आगे के पीछे, in the positive or in the negative x direction, so that the center of mass remains at rest. ये जो m1 है, it goes in this direction towards m2 by distance d, small d. What should the displacement of m2 in the forward or in the backward direction that we have to see, so that the center of mass remains at rest? There should be no change in the position of the center of mass. Obviously, अगर ये आगे जाएगा और इसका मोमेंट नहीं होगा तो सेंटर ऑफ मास शिफ्ट हो जाएगा, क्योंकि एक मास का कोऑर्डिनेट चेंज हुआ और दूसरे का कोऑर्डिनेट अगर चेंज नहीं होता है तो इसका मतलब सेंटर ऑफ मास पोजीशन चेंज होगा। लेकिन अगर मास m1 का पोजीशन चेंज हुआ, m2 का भी पोजीशन कुछ चेंज होना चाहिए ताकि सेंटर ऑफ मास एक ही जगह रहे। तो क्या टेक्निक हम इस्तेमाल करेंगे? फर्स्ट आई विल राइट व्हाट इज द सेंटर ऑफ मास पोजीशन, एक्सियम, that is m1 x1 plus m2 x2 divided by m1 plus m2, right? That's the base formula. Now let me take the changes from both the sides. I will change this center of mass position, that will be changing of x1 position and x2 position. So change in the x1 position and change in x2 position will also have a corresponding change in the center of mass position. मतलब ये कि अगर x1 चेंज होता है, x2 भी चेंज होता है, let me suppose center of mass will also change. So I will write taking the differential on both sides or change on both sides or differentiating both sides, वो सब चलेगा. Have a look. Delta cm, delta xm, change in the position of the center of mass is equal to m1 change in the position x1, I mean change in its position, plus m2 change in the position of x2 that we have to find, divided by m1 plus m2. It is taking the differential from both sides or taking the change from both sides. After all, जब आप ये change करोगे, ये change होगा सिर्फ इस x1 और x2 की change की वजह से. m1 m2 are anyway constants. लेकिन this is given to be 0. There is no change in xcm. Sorry. xcm में कोई change नहीं है. That's why we can write it 0. So it is m1 delta x1 plus m2 delta x2 divided by m1 plus m2. उससे क्या होगा, ये उठाकर यहां पर रख दो, 0 हो गया. तो इट इज 0 इज इक्वल टू m1, ये डेल्टा x1 जो है ये तो d है, दैट इज गिवन टू बी बिकॉज इट हैज गॉन इन द फॉरवर्ड डायरेक्शन d, तो इसके चेंज में d आया है, इस ये चेंज, प्लस m2 डेल्टा x2 निकालना है. तो बताइए डेल्टा x2 किसके बराबर है? वो है बराबर, ये शिफ्ट कीजिए m1 बाय m2 इंटू d. आंसर. इसका मतलब ये जो m2 है इट शुड शिफ्ट टू द लेफ्ट बिकॉज ऑफ नेगेटिव साइन. ये ठीक बात है, अगर ये आगे जाता है ये पीछे आना चाहिए ताकि सेंटर ऑफ मास वही रहे जहां ये पहले था. ओके, क्वेश्चन नंबर 6. Sixth question. These are two masses m1 and m2 initially at rest. Okay, then they start attracting towards each other under their own force of attraction. Maybe they are gravitating bodies and they attract each other. When they attract each other at a particular time, its velocity is v and mass m2 has 2v velocity. Possibly m2 is lighter and is moving faster. When its velocity is v and its velocity is 2v, what is the velocity of the center of mass? Question is, what is the velocity of the center of mass? What is the velocity of center of mass when m1 velocity, when v1 is equal to v and v2 is equal to 2v in the opposite directions, of course. Try to understand the question. Initially the two bodies were at rest and they started moving under their force of attraction F and F, because maybe they are gravitating bodies or maybe they are charges, or one is positive, other is negative, they start attracting each other. So after a little time, its velocity is v and its velocity is 2v. What is the velocity of center of mass at that time? That's the question. Question is very a little tricky. What is the velocity of center of mass? The velocity of center of mass is equal to 0. Why? Why? Because initially the two bodies were at rest. Initially the two bodies were at rest. It was m1, it was m2. The body, they were at rest, and center of mass was here, and the center of mass velocity was 0 at that time when they were at rest. Now they started moving towards each other. There is no external force. These two forces are internal, and these two forces will not change the velocity of the center of mass. So the velocity of center of mass will continue to be at rest. You understand my point? Something like this. Suppose there are two bodies like this, and center of mass is somewhere at the middle. When they start moving, one may be heavier, other may be lighter. The heavier one moves slowly and is faster, but center of mass is there where it is. Something like this. Center of mass is here, would like this, like this, like this, and they will collide at the center of mass. Center of mass wahi rahega. So it's something like this. Center of mass is here. This body will come over here. This body will come over here. Center of mass again there. This body will be here, this body will be here, center of mass again here. So, because the basic reason is there is no external force. Only external force will change the velocity of the center of mass. That I have talked to you initially. So, answer is the center of mass velocity is 0, because initially the center of mass velocity was 0, and after at any time, whatever may be the velocity of the two bodies, the center of mass velocity continues to be 0. Why? Reason kya hai? Because there is no external force. Internal forces cannot change the velocity of the center of mass. Seventh problem. This is one more problem on this velocity of the center of mass, or the change in position of the center of mass. It's a boat here on water, and on the boat there are two persons at the extreme ends, and the length of the boat is 2 meters, right? As a water is supposed to be relatively frictionless. But if you move on the boat should move in the backward directions smoothly without encountering any friction with the water. This is a person 80 kg weight. This is a boy or a weak person with 50 kg weight, and this person rushes towards this end, and this person rushes towards this end. What happens? This person goes over here, 80 kg, and this person comes over here with 50 kg, right? Weight mass 50 kg, and the length of the boat is 2 meters. We have to see when this person goes over here and this person comes over here, what is the motion, what is the displacement the boat undergoes, और ये boat जो है कितना displace हो जाएगा water में in the backward direction या forward direction में ही, वो हमें देखना होगा. Will the boat go in the forward direction or backward direction? Now, how to solve such a problem? I have to find what is the shift in the position of the center of mass of the boat. Shift in the center of mass of the position of the boat. हर एक का सेंटर ऑफ मास शिफ्ट हुआ है, इसका भी बोट का भी, लेकिन टोटल सिस्टम का सेंटर ऑफ मास एक ही जगह रहे. एक तो हुआ सिस्टम, पूरा सिस्टम जो है, इस सिस्टम का जो सेंटर ऑफ मास है दैट रिमेन्स अनचेंज्ड. लेकिन इस सिस्टम में जो भी ऑब्जेक्ट्स है, बोट है, पर्सन्स है, वो अपने सेंटर ऑफ मास चेंज करते रहते हैं. Due to internal forces, they change the center of mass of the individual bodies there inside. लेकिन total system का जो center of mass कहीं पर है, that will remain unchanged. वो change होगा नहीं, because there is no external force. All the forces are internal. The persons, the two men, they are rushing towards each other and get to the ends of the boat. वो internal force की वजह से. Let me listen again. The total center of mass of the system of two persons in the boat is fixed. Total center of mass of the system. But center of mass of the individual bodies change. They change in such a way that the center of mass of the total system should remain unchanged. तो किसी ने center of mass आगे लिया, तो कोई और center of mass पीछे लेगा सिस्टम का. जितना ये सेंटर ऑफ मास आगे लेने की कोशिश करेगा सिस्टम का, उतना वो बॉडी जो है वो पीछे लेने की कोशिश करेंगे, ताकि सेंटर ऑफ मास ऑफ द होल सिस्टम रिमेन्स फिक्स्ड। तो मुझे आप बताइए, who takes the center of mass to the right side, and through who takes the center of mass of the system to the right side, and how much it takes? 80 goes to the right. How much? This distance. So 80 into 2 minus x. This is the this person tries to take the center of mass of the whole system to the right, but center of mass of the system has to be fixed, is equal to, who takes the center of mass to the left? This one. This one. How much distance it travels? It goes from here to here, but it goes actually from here to here with respect to a person on the ground. It goes from here to here on the boat, but it goes from here to here with respect to the person on the ground, because boat has gone in the backward direction. So it is 50 into 2 meter plus x, 2 plus x. This takes center of mass to the left of the system, to the left, but it is quite heavier. This is again heavier. 80 जो है वो heavier है 50 से, इसका मतलब 50 को सपोर्ट करना चाहे बोट भी इन द बैकवर्ड डायरेक्शन, प्लस हाउ मच दिस बोट टेक्स center of mass of the system to the left, that is mass of the boat, that is 70 into this x, because it goes only x to the left. That is all. This takes the center of mass of the whole system to the right, this takes to the left, and this boat also takes to the left. Whatever the effort in the right direction should be equal to efforts in the left direction, so that center of mass remains where it is. Whole system, one person takes the center of mass of the whole system to the right, the other object should take the center of mass to the left, so that center of mass remains where it is. So this is the equation, base equation. So it is 160 minus 80x is equal to 100 plus 50x plus 70x. This is, push it to the right side, you go 160 minus 100 is equal to this 80, 50 plus 70. So okay, 80x plus 50x plus 70x. This is 160, or is only 60 is equal to, how much it is? It is 120, this 200x. 1 cancels, so that is x is equal to 6 by 20 meters. If I want to make it centimeters, it will be multiplied by 100. This cancels. It is 30 centimeters should be the answer. The boat should go to the left side by 30 centimeters. So the center of mass of the boat will also shift by 30 centimeters. These were few problems on the motion of the center of mass of the systems. You do it, practice with it, and next lecture maybe I will go to the acceleration of the center of mass, which forces are responsible to accelerate the center of mass of the system. Thank you, but don't forget to download the app, Nazir Physics class, and watch my lectures on the YouTube. I'll be continuously delivering the lectures on the YouTube, so that the students in general can be benefited. Okay, thank you.